Hello everyone. Today we are going to talk about electrical resistance. So when you're thinking about electricity, there is the rate at which electrons flow through a wire or a circuit, and how fast or how easily those electrons move through the circuit depends on the resistance. And resistance is what we're going to talk about today. So other characteristics of a circuit include current and voltage, but we'll get to that next week. For now, let's get on into resistance. So if you imagine yourself driving down a road, which type of road would you want to drive down? Would you want a really hilly road? Would you want to just go straight downhill all the time? Would you want to drive on a really jank road, like this one right here, where half the road is missing, it gets really narrow? What about this one, where it's like really long and twisty? What type of road would you want to drive down? And that's kind of what you have to think about when you think of electrons moving through a circuit. What type of circuit would be easiest for electrons to go through? Well, there are a few different factors that can change how that resistance, or how much resistance is in that wire. So resistance can be thought of as electrical friction. It's opposition to the flow of moving electrical charges. So the electrons are trying to move through your circuit, and resistance is how much pushback there is on the electrons. What's slowing them down? Why can't they flow as fast as they can possibly move? What's preventing them from moving quickly? So when you think about a circuit, we often draw resistors as these little squiggly lines. So this part would be a continuation of the circuit, and the resistor is just several jagged lines, and then it continues on to the rest of the circuit. We usually represent resistance with an R, capital R. Now, the unit for resistance is measured in ohms. So later on in this unit, we'll be calculating resistance based on the circuit's voltage and the current. And the unit we use to represent resistance is, of course, ohms. It kind of looks like this omega. We won't do any calculations today, but we will definitely get in that next week. So this is a cute little picture. Resistance is futile. If resistance is electrical friction, what benefits could resistance provide when making a circuit? So how can you use this resistance to your advantage? Well, it turns out that's exactly how light bulbs work. You have a light bulb, and the resistance and the wire right here is what makes it glow. In fact, we'll see later how temperature of a wire can actually change the resistance as well. So light bulbs actually glow because of resistance. Well, resistivity depends on what the material is made out of. So one of the four factors that can affect resistance is what is the material made out of, or what is the wire made out of. Is it made out of aluminum, copper, gold, silver, nichrome, I don't know if I'm saying that right, or tungsten. So any of these could make up your circuit, but depending on which one you use, it has a different amount of resistance. So you can see aluminum, and you can kind of ignore this times 10 to the negative 8. If you just kind of look at these numbers, you can get an idea of which ones have higher resistance. Copper is about 1.7, so that's low compared to gold, which is 2.4, or tungsten, which is 5.6. So copper is very conductive, or it has less resistance than other metals. And you can see silver as well has a really low resistance. So choosing your material wisely can actually decrease the amount of resistance your circuit can have. And of course, all these are at 20 degrees Celsius. We'll come back to why that's important later. So resistance slows down moving electrons. When electrons slow down, they convert energy, or electrical energy, into light, heat, and sound. So this is why light bulbs glow, because as those electrons are moving down, or they're slowing down because of resistance, they start to glow and release heat and light. So the 4 different things that I've mentioned, the 4 different factors that can affect resistance. One, like I said earlier, was the type of material. So choosing your material wisely can change how much resistance your circuit has. And this is why light bulbs are made out of a very specific material to increase that resistivity and allow the light bulbs to glow. And of course, this whole PowerPoint will be posted on Teams later, so you can review it whenever you want. The length of the wire is another factor that's really important to resistivity. The longer a wire is, the more resistance the electrons experience. I mean, imagine if this were a really long road, it would take a lot of energy to get down that road, whereas a very short path would not take as much energy. And so the longer the wire, the more resistance it experiences. The longer the path, the longer it takes to get down it. Another factor is the thickness, also known as the cross-sectional area of the wire. The thickness of the wire can greatly change the resistance the electrons experience. So the thinner the wire, the more resistance the electrons experience. Imagine trying to fit 50 cars down a 1-lane highway versus 50 cars down a 5-lane highway. It is a lot easier as the road gets wider or thicker. So the thinner something is, the more resistance there is, but the wider or thicker, the less resistance the electrons experience. This is why many of those telephone wires will be very, very thick cables. It allows a lot of electricity to flow without much resistance. Temperature can greatly change resistance as well. In fact, the colder a wire is, or the colder the circuit is, the less resistance it experiences. So the longer you have a circuit running, the hotter it gets, the more resistance it experiences. And so as it heats up, it actually becomes more resistant, hence the glowing from a wire. So temperature is one of the 3 factors as well, or 4 factors. So let's review that again. The 4 factors were the type of material, so what the wire is made out of, the length of the wire, the thickness of the wire, and the temperature in the environment. So, problem of the day, is resistance in a wire always bad? Well, no, because light bulbs, like I said earlier, resistance is what causes those light bulbs to glow. Without resistance, we would have no light bulbs. How different types of light bulbs work, you can actually click on this link and you can go to that video and watch it if you would like to. Once again, this video, or this PowerPoint, is posted online, so if you would like another resource, you can use that. And that's pretty much all I got for you today.